I'm going to talk to you today about some of the ways that I've been incorporating full-blown projects into my classrooms. And I'm tempted right now to just start telling you all about it, but I think I need to go through the slides. But a big picture, it's in science classes, we have labs, and so in some ways, science is just kind of naturally experiential, and we're always doing, some fun little project in a lab. But these fun little projects that you often do in laboratories are usually canned in a lot of ways, so it's not like a real project that you're going to win the Nobel Prize for someday. And so it's, there are some barriers to utilizing and engaging in real projects in the classroom. And I'm going to talk about a few of those. But let's go ahead and start running through the slideshow here so I can stay on track and not just ramble on. So I started out the slideshow with this, and kind of standard classroom stuff, which, by the way, I'm going to be guilty of right now. Like, you were just out in the hall doing this cool stuff with those little robots, and I got these slideshows. It's 4 in the afternoon. I'm going to have to throw stuff at you probably to keep you awake. But anyways, the younger folks like yourselves, I used to be a young folk too, but I didn't have all this stuff that could distract me now. So we have this big question from the teaching standpoint: why are students distracted, sleepy, and unable to show up to class on time? Well, we know all the reasons for this. Staying up all night playing video games, Snapchatting all night, drinking coffee and power drinks all day and all night, all this good stuff that, contributes to the snoozing student in the class. So, keeping students' attention these days is even more difficult than it's probably more difficult than it ever was because of all the distractions. And so the question is, can we keep their attention, engage them in ways that might really fundamentally connect with them? And so this idea of fundamentally connecting with a student is a really important one, at least in the way that I think about things. And, different students, you folks are all aware with all your friends and colleagues and so on, there's, some students do great with a lecture like this where you put up a bunch of factual information and they absorb it all, they take it home and read it, and they're excited about it. But that's probably really the vast minority of students. Most students need some sort of physical engagement to really fundamentally be connected with what it is they're learning. So it's a big problem in big classrooms with 30 students in it. We're going to talk about that here in a little bit. So anyways, project-based learning. It's a concept that's been around for a long time. I'm going to talk to you about a couple of historical figures that were involved with project-based learning from a long time ago. But anyways, project-based learning has its potential for a paradigm shift in the modern education system. And it truly would be a paradigm shift. And hopefully as we go through here, you'll understand why that is. Lots of questions involved with project-based learning. You're going to see a lot of my slides have questions because I don't really know the answers. But anyways, project-based learning, how do we assess this? Do we assess it with kind of standard testing that we always do, or are there other ways that we need to assess? And that second question there, is testing still necessary? It's a good question. And there's another question there, does it really make a difference? And as I just mentioned, some students are going to be, just fine with the old way of doing things. Some students might not like the project that you're working on, and you're not going to get them. You have to come up with another project. Suddenly you're like, oh, yeah, what? I got to come up with 10 projects to make everyone happy. Doesn't make sense. But this question here, does it really make a difference? As a scientist, I'm always interested in if you think you're doing something to make a difference, to induce a change of some kind, well, you got to measure it. So there's ways that we can try to measure whether we're making a difference in learning. But the reality is that it's really difficult to measure whether you've made a difference in learning. It's difficult to measure learning. We do it with tests, and we can measure certain types of learning pretty well with tests, but overall learning, long-term learning, big picture conceptual learning, sometimes really difficult to determine whether students are really learning anything at all, even if they're doing well on your tests. So anyways, project-based learning, it's not a new notion. There's a famous American philosopher / psychologist from the early to mid-1900s was a strong proponent of experiential type learning, and he developed an entire philosophy based on what they called pragmatism, which is essentially, to learn you must experience. But the early 1900s was a little while ago, wasn't that long ago. Aristotle, back in the 300s before BC, had the same idea. So it's in terms of Western civilization and Western thought, which all originated with the Greeks, this idea of experiential learning was basically invented way back then. So the idea has been around for a long time. Well, I'm not an educational theorist. I'm a biologist who teaches students about biology, and a big part of my job in the biology department is to prepare pre-health professions students, pre-med students, pre-nursing students, pre-physical therapists, prepare all these kind of, pre-clinical medicine students for their entrance exams so that they can pass their entrance exams and get into medical school or nursing school. My main job has been to, basically give these students a bunch of facts, teach them some stuff in the labs, and hold their nose to the grindstone on the test. Like, you got to learn this material. It's going to help you get into your professional school. It's going to help you save people's lives in the end once you do get through your medical school or whatever it is. So my past has been pretty straight and narrow in terms of the ways that I deliver information and expect learning to happen in my classroom. So anyways, I'm not really an educational theorist. I've had the opportunity over the years to work with lots and lots of students on small projects. And so I always have little research projects that students sometimes work on, for a term. Sometimes they'll work on it for an entire year. Sometimes I've had some students work on my projects for 2 or 3 years. So I'm used to working with individuals or small groups of students on long-term projects. And so it's sort of a project, that style of project-based learning in that environment is natural to me. When Dave asked me to do a presentation here, I went and started doing a little bit of reading about project-based learning, and it's now a full-blown kind of subfield of education, and there's a lot of kind of development, technical development in terms of how do we deliver project-based curriculum. And I found this one, well, it's an institution actually, the Buck Institute, but it has hired people to develop a way of delivering project-based learning curricula. And so they have a pretty involved prescription for project-based learning, and I'm going to show you that here in a minute. But they say something, and again, these are questions that I myself have, and it's interesting to me that they say that project-based learning is not simply doing a project. And like, if you have questions about that, I'm sure they're probably right, but I haven't come around to understanding why that is, because I think in my own experience with students, it's been like, okay, we're going to do this project, and then you got to learn all the stuff that you need to do the project, and so they learn while they're doing the project. And I'm going to talk a little bit more about that here in a minute. So anyways, I just wanted to show you their kind of, I call it a prescription. It's basically the elements of a project that you're going to use in a teaching setting. And if any of you, what I understand is that you are students who are going to be interested in becoming teachers, and so this PBL works here, and their kind of prescription, their elements of design, as they're calling it, is might be a good thing for you folks to access if you ever get interested in this. And they have a lot of good description, and you can call them up. They have they'll work with you and help you set these things up. And so it's a pretty involved and extensive program that they have. As far as I could tell, it's all free too. Anyways, I'm not going to go through all the details here, but they have it all broken down into the things that need to happen in various stages, and so that's a nice colorful diagram there. And then they got another one that kind of outlines the gold standards for the teaching practices. And I'm not going to run through that in any kind of detail. I'm just showing you these things to let you know that these are resources that are available to you. So just as I was kind of saying before, this formulation is highly organized and well thought out. And from my perspective, it was a bit theoretical and abstract to get my mind around in terms of how does, when the rubber hits the road, what actually goes on here. And because I've been running project-based curriculum for a couple years now, I have my own set of design elements, if you will, and they're pretty straightforward. And I'm going to bring this out here so I don't have to keep walking back in there. So, if you think about a project, try to do something. And in science, we're always trying to answer questions. Why is the sky blue? Why does the wind blow? Whatever it is we're trying to answer. Why do these little bugs wiggle this way instead of that way? So you got to come up with the project, and Then once you've come up with a project, you have to gather information about it. And, hopefully what happens with a project of any kind these days, usually you're going to collaborate with someone. And you may know something about one part of the project. There's going to be some expert that's going to know a lot more than some other part of it than you do, and you're going to collaborate them. So projects are really all about teamwork these days. You might write a grant to try to get some money to carry out the project. You might have to gather together partners, scientific partners or community partners if you're trying to involve the community in some way. So lots of information to gather, and that might involve gathering together experts who know more than you. Securing funding for the project, I just mentioned that. Usually most things that you try to do, you're going to need some money to get it done. And then you got to carry out the project. And one thing about projects is they don't always work the way you think they're going to, especially science projects. And really accomplishing a project and the learning that goes on during the sort of carrying a project to its end and finally getting to your goal, the learning that goes on really involves failure and revision and repeated cycles. And this is a lot of the, I haven't read a lot of the education literature, but some of the stuff about, problem solving and this idea of failure, like everyone's afraid to fail. Well, in science, we fail all the time. We think, well, we have a hypothesis. We think this is the way it works. We go do a bunch of experiments and we find out that, whatever it is we're looking at doesn't work in any way that we thought it did. Or we might just screw up the experiment because it's so technical that, we dropped our sample on the floor, the one that we just spent the last 2 months preparing. So now we've got to go back and spend another 2 months preparing another one. So anyways, this idea of you got to try things out and see if they work. It's super important. And then that fifth thing there, if you engage in a project, in a real project as a professional scientist or as a professional community builder, whatever it is you're doing, you always have to be able to kind of present your public face. You got to be able to communicate what you've done. And so this is always part of a project, is to communicate what you've done to whoever you can find who wants to listen to you. Sometimes maybe there aren't a lot of people who want to listen to you, but if you just spend a bunch of money, like if you had $1 million NIH grant, people usually want to listen to how you spent that money, at least. Make sure something good happened with it. Okay, anyways. So here are some of the issues with project-based learning. These are just sort of things that I've read about and that have come to me through these past couple years of really engaging in project-based learning. And beyond that, in thinking about project-based learning, actually for a long time, for decades, because I always had this sort of a fantasy that I was going to be able to somehow teach an entire biology curriculum just through a project, nothing else. No real lectures, no canned labs, just do a project. Take a cohort of students, take them through 4 years of that. I think we're still a long ways from doing that in that kind of raw form that I just described, but it is an interesting idea. Anyways, issues with project-based learning, projects in science really require small class sizes. I'm going to talk to you a little bit about this Bull Run Creek project here in a few minutes. But small class sizes don't really mix with kind of the modern way that we do K through 12 and higher ed these days. It's not financially viable to run class sizes because we need to pay more instructors if we're going to do that. But really, if we're going to do bona fide projects, there's no getting around it. We need smaller class sizes with small cohorts and instructors who are basically the project leaders to help the students do what needs to be done to actually accomplish the project. And that brings me to my second point, which is that real projects require high levels of knowledge and high levels of expertise. If you're going to write a grant to clean up some sort of toxic environmental spill site, we call these sites brownfield sites. If you're going to hire someone to clean these things up, they got to know what they're doing. And you really can't just go out with a class of your 8th graders or 10th graders and clean up a toxic waste spill. You got to know what you're doing. You got to be able to do the analysis in the end to figure out if you've actually done the cleanup you thought you did. Lots of stuff going on, and the technical knowledge that you have to do this means that you have to have one or more experts involved in the project, and that means that somehow, back to the money thing, you got to hire the experts or get them to volunteer their time or, something like that. But the point is that the levels of knowledge that are required to really carry out a project and be successful with it are extremely high. And the expectations from whoever's hiring you to do the project are going to be high too. And so this idea of a real-world project is a great idea, but the students in your classroom are going to be so far away from being able to do it. And the idea then is to figure out how far along you can get them in that world of understanding that they would need eventually to really do something like that on their own. And then if it's a real project, the trick is that if you're responsible for the project and making it happen, and you have these students who are just learning how to do these things, and they're going to fail for sure as they're learning. You might have to do some of these things 2 or 3 times to get it right, kind of thing. Is that going to be built into the project so that the people who funded you are going to understand that, well, part of this process is an educational process for these students. So anyways, those are some kind of things that need to be thought about when you're considering project-based curriculum. The resources are often daunting, like the money you need to do a project. You might think, oh, well, there's a place out there where, some factory was dumping a bunch of some chemical into the river or something, and you might think, well, let's write a grant to get this cleaned up, and it's oh, wait a minute, this ends up being $1 million grant to really get it done, and suddenly you're millions of dollars, and it's big time to actually get this project done. So, related to that previous point, the number of real-world projects that can get funded, like these big projects, $1 million projects that are funded, are limited. And if we're trying to do this in every classroom in every school, suddenly we're going to run out of real-world projects. Another practical point there that I just kind of tagged on the end, and this is something that I've noticed through years of running projects with just small numbers of students. As soon as you get above 4 or 5 students in a group working on a project, what happens is that the most engaged and maybe the most knowledgeable students end up being the ones who are doing all the work, and the rest sit around and watch. And so you get, like, if you have a classroom of 8 or 10 students, and they're working on a single project, there's only so much that can be done at any one given time. One person does the thing that needs to be done at that time, and the rest are sitting around watching. And so managing that so that they all get a chance to do all parts of a project is a little bit of a trick. It's one of the problems that needs to be solved. So, anyways, this is another interesting thing, because then this is again because I'm the biology curriculum that I've delivered to most of my students has been highly content driven, and lots of content-based knowledge is expected from these students when they graduate from our program. You get them onto a project, and a project can be very focused, and you lose a lot of breadth and knowledge by focusing the time on the project. And so you got to think about that trade-off. The pre-med students, for example, they need a huge knowledge base in order to get into medical school, and then eventually in order to go practice. And, is the project-based learning curriculum the best thing for these pre-medical students? Well, I don't know. In some ways it might be good, in other ways it might not be so good, because they might lose out on that huge knowledge base that they need. So, now, because I do science projects, this is right up my alley, and science is content driven in a lot of ways. On the other hand, in a lot of ways, it's not content driven, and that's sort of paradoxical there, because the important thing about science is that, oh man, can you come up with a question? Like, do you have some curiosity about something? It's like, oh, that's cool. Why is this little insect able to, sense chemicals from a mile away and fly straight to those chemicals? These chemicals might be released from a flower or from another insect, but why does that happen? How does that work? Well, we're going to ask that question. We're going to figure out how to answer the question. That's critical for science. But then, like, if you have that question, what you got to do is you got to go into this huge base of literature and say, well, maybe someone else already did that experiment. So we might have the answer to the questions. We just have to read about it because someone else already did it. So huge amounts of knowledge and huge conceptual framework that you have to have in order to actually ask the cool questions and answer the cool questions. Okay, well, I just talked about large classes there, so I don't think I'm going to say much more about that. So now I'm just going to tell you a little bit about what I'm doing with projects. I rambled on a little bit more than I wanted to with this first part. Well, first off, we came up with, a couple years ago, a new degree program here at EOU. It's called the Sustainable Rural Systems degree. And this is just a slide showing you what sustainable rural systems are. And that natural resources bit there at the bottom is super important, because it turns out that all human activities derive from the ecosystems that we humans live in. So all the stuff that we have around us comes somewhere from the planet. And even when we go in and you might say, well, if we extract some metals, get some iron or some gold or some platinum or some cadmium or some mercury out of the earth, well, that stuff may not be directly in the ecosystem, but the ways that we get that stuff out of the earth disrupt ecosystems. So these natural resources are critical for sustainable human systems. I just put human in place of the rural there because we can think of this in the broadest way, not just in terms of rural communities. Anyways, I'm not going to spend too much time on that slide. So this slide just is a slide that that shows what we want students to come out of the program with. So it's a 4-year degree program. And these main things that are in the thought bubbles there are kind of normal things that you want probably students to get out of any class that you would teach them, actually, at some level. But critical thinking, cultural understanding, scientific information, can you apply this to real life situations? Community problems and creativity to make decisions about what is going to be done with the community at any given point in time. So anyways, the upshot is a broad base of conceptual knowledge in economics and sociology and biology. So here's where we get to the project aspect. Now, this new degree program has a huge project component. And what we do is we engage students in a multi-year project. And the projects that they're engaged in right now are what we call brownfields projects. They're these environmental cleanup projects. And so we engage the students in the same project for 3 years. So you have a sustained involvement in a project. And actually, if you look at the PBL works, elements of project design there, that's one of the things that they do have in their design wheel, is that, if they do a project, for half a term in one of your classes, then, that's something, it might help. But if they do that project and they're engaged in it for 3 years, that's way different. Like, suddenly they're really engaged in it. They're going to remember a whole lot about it. They're going to absorb a whole lot about it. So sustained engagement, involvement with the project is important. And we thought that that was important when we designed this degree. So we have it scaffolded then for a 3-year involvement. Okay. Well, the class that I teach in this degree program is a science class. And what I did with this class was I decided I was going to run the class as a project. And so I got together with the Forest Service, with the Confederated Tribes of the Umatilla, with the Upper John Day Watershed Council, and we came up with this project for the students to do. And so my students in this class now are involved for an entire term with the project. And then it turns out that that class is also a gen ed class, so it has students who aren't actually in the degree program, but there are some students who are in the degree program. They actually continue to be involved with that project for a second term. So essentially they get involved with this project for 2 terms, which is pretty long and extended. And it's like a good dose of a project. So the project is really cool. I'm really excited about this project. It's a restoration project up on a place called Bull Run Creek, which is in the Upper John Day watershed, which, do any of you know where Granite and Sumter are? I see some heads nodding out there. Oh, a lot of heads nodding. So if you go, go down to Baker and then up past Phillips Reservoir, or you can go up to Anthony Lakes and continue on behind Anthony Lakes there, and you get to the North Fork of the John Day River. And so Bull Run Creek is is a tributary of the North Fork of the John Day River. The North Fork of the John Day River is, of course, a tributary of the main John Day River, which is a tributary of the Columbia River, which runs into the ocean there. And so these these salmon and steelhead, then, they come up the Columbia and up, and finally they come up into little creeks like Boron Creek and they spawn. And then the hatchlings grow a little bit and they make their way back down to the ocean eventually. The John Day River is the longest undammed river in Oregon and one of the longest undammed rivers in the continental United States. And Bull Run Creek is one of the best spawning grounds for salmon and steelhead in the John Day drainage. Now the problem is that I say it is one of the best creeks. I should say it was, because it was essentially destroyed by placer mining, and that's what, you can't really probably see those pictures very well there, but they're showing you the completely disrupted riparian zone there. Anyways, the restoration project is aimed at restoring the salmon habitat there. And one of the things that they want to do in order to restore the salmon habitat is they want to get the beavers back in. In order to get the beavers back in, they got to slow the water down because they channeled the creek so that it just goes straight down the valley and it washes out the beaver dams every time the beavers try to build a dam. So they got to add a bunch of meanders back into the creek so the water slows down so the beavers can move back in. Once the beavers move back in, then we'll have great fish habitat again. Anyways, my students are going up there and collecting what we call macroinvertebrates, these little wigglies that you're going to see in my next presentation. So that just shows you what I already told you there. Okay, so that was the Bull Run Creek project. The other project that I've been involved with for several years now is it's an outdoor class that I teach at a place called Cottonwood Canyon State Park. And I teach that class to high school students. And it's a really fun class to teach. And what we do is we do a little project throughout the course of a week. And this project it's aimed at generating data for data that will help understand the health of the John Day River at this location. This location is about 25 miles upstream from where the John Day River dumps into the Columbia. Anyways, it's a really cool outdoor classroom because what I get to do is go there for a week and I get to take the students through all the steps of a project. And it's a mini project, and it's a project that's not funded by any big funding agency. And it's a project, that eventually I'm going to write a paper using the data, and I'll get a nice little publication. I'll contribute to the science. So it's real world in that way. And it's an example of what you can do without big time funding. And so I'm just going to take you through what the students have prepared at the end of this. So remember on one of those other slides I said, okay, you always got to present your findings, whatever it is you've done with your project. You got to write it up in a report. You got to present it somehow. So that's what they do at the end of this. And I'm going to take you through their slideshow and tell you what they do along the way. And it's the kind of thing that you folks, if you become teachers at some point, you could use this as a model. You could say, oh, wow, geez, we could actually do this, in a week's time. Well, I had 5 consecutive days. You might have to spread it out. You could spread it out over, 3 or 4 weeks or something like that. Depends on how you could set it up, make adjustments. So let me see if I can get to my other slideshow here, and it looks like I'm going to run out of time, so I'm going to go through this quickly. Okay, well these are my 4 students this year, and so what happens is they come in, and I give them a brief introduction to ecology and to the John Day River, and then we go out to the river and we start collecting macroinvertebrates, and you're going to see some of these here. They got a lot of cool pictures that they took. I bring microscopes down. There's a building there called the Experience Center, and so we get to set up microscopes and take pictures and videos of some of these critters that they're catching. So they get I give them a little short lecture, theoretical aspects of ecology and riparian zones, and then we go out to the river and they start collecting. And so again, this is their presentation that they gave on the last day. Here's some of the organisms that they collected. They wanted that funny thunderbolt or whatever it was, thunder sound. So you can see there, we're doing some technical stuff. We're not just going out and wading out in the river and scooping up bugs. It's not that simple. You're setting up transects, sampling every 5 meters. We're doing this in a systematic way. So they're learning some kind of, basic methodologies of this kind of science. There's the methods. So here's some of more of the critters they found. That's water penny. Diatoms are really cool. They have a cell wall that's made out of glass. And so when the organism dies, then the glass shell just sits there and you can see it. But they're really cool. They have this thing called a raphe. It's a little opening, and they stick part of their membrane through it and they crawl along. Anyways, fun stuff. So they catch these things, and then they get to sit down on the microscopes and take pictures of them. And so they have a lot of fun. And they're learning a bunch of, $20 words at the same time while they're doing it. And they get to practice saying those $20 words when they give the presentation. Here's another one called an ostracod. These guys are related to shrimp. So that was the easy part, to catch those things and take pictures of them. They get to do a lot of math in this little project too. So it's a really good kind of integration of science and math, and then writing in the end when they prepare this presentation. But I'm not going to go through the details of the results there, but this percent dominance we use a simple equation there and come up with some graphs. We use this big hairy equation right here to come up with some other numbers that give us some ideas about how diverse the communities are. By communities, I mean the communities of organisms in the river at that place. And then there's the summary of the findings. So anyways, they get to engage in this, collecting the organisms, counting them up, doing some mathematical manipulations of the data to help us understand the biodiversity there. And then the other thing that we look at is the tolerance of the organisms, how sensitive they are to pollution and to degraded waters. So anyways, that's a nice kind of outdoor setting where we all have dinners together and we kind of hang out in the evenings and have a lot of fun, but we do a lot of hard work too. And they learn a lot. So this to me is a good example of if you can get a small number of students and focus them on a project, they'll engage and you'll get a lot done and they'll learn a lot in a fairly short period of time. But of course, we're there for 5 days working all day. It's totally different than the model for teaching that we have now. So I think about, well, gosh, how could we do things differently? Could you take our students, instead of breaking up the classrooms into different classes every day. Let's spend 2 weeks, 3 weeks every term just doing one subject. And you could go out and spend all day. You know, you don't have to go camp out anywhere, but you could go out every day and do stuff. Anyways, there are different ways you could think about delivering curricula and quote unquote teaching. Anyways, I've droned on long enough now, and that's the end of that. Okay. All right. Well, you guys get to go eat now?
No, I have one more.
One more.
Any
Well,
questions for John? I have a question back here.
Yeah.
Do you have any suggestions of a way to help the projects be more fair so that students contribute like equal amounts? Because I've always noticed that when we do school projects, there's always one person doing most of the work and one person that's always styling. And teachers use lots of different methods, but I've never really seen one that actually works.
Yeah, I'm probably in the same boat as your experience. I mean, I oftentimes just, like, I'll force the issue. I say, look, you know, like, you need to start contributing. And in this small setting, it oftentimes works. It's a problem, and you end up with people who just don't want to engage. And the other thing that happens is that oftentimes that you have this one or two people who are a lot faster than the rest, and it's not that the rest wouldn't do it. The others wouldn't do it. It's just that those two are so fast, and they just start doing it to get it done. And everyone's like, oh, yeah, you guys are good at that. And I think it has to do with this idea, it's sort of a mindset that, like, oh, if you're good at it, then, you know, we should find someone who's good at it and let them do it, and then I'm not going to do anything. Rather than the mindset of, well, even if I'm not that good at it, I should learn about it and maybe get a little bit good at it. So, I mean, the way that I've done that, what I do, if I notice that someone is like taking over and doing it all, I'll pull them out and have them do something else and switch the other people in and say, okay, you guys need to get this done now. I'm going to have, and then everyone's like, oh, but, she's so good at it. And I'm like, yeah, well, I want you guys to get good at it too, so that you're like her when you're doing it. And we can all cheer you on. And I think they kind of appreciate that. I just want them to, get better at it and help them understand things in the end too, because there's like an understanding part of all this, especially with biology, and then there's a kinesthetically, can you do it quickly with your hands, that kind of thing. So my approach has just been to pull the fast people off that part of the project and tell the slower ones that they just need to do it and find something else for that fast person to do it. And they don't always like it when you do that. They might complain a little. But in the end, I think the people who are just kind of sitting around watching appreciate the fact that, oh, wow, gosh, I can do this. And it's not as hard as I thought it was. Anyways, I don't know if that really answered the question, but.
Any other questions? All right.